Hi everyone, welcome to ANR Academy. This is Nepal Reddy sir. Today we are going to discuss the nature of roots of cubic equation. See the cubic equation f of x equal to ax cube plus bx square plus cx plus d equal to 0, where a is non-zero real number, remaining b, c, d they are any real values. Since it is of cubic equation, it has at most 3 roots, and the roots may be real or maybe the roots are complex. Suppose that the function f of x has only one real root, implies the remaining 2 roots must be complex, and we know that complex roots are conjugate, so that yes, there is a possibility to get one real root and 2 complex roots. Next, suppose if it has 2 real roots, then only one complex root is impossible. Why? Because complex roots are conjugate. Next, suppose the function f of x has 3 real roots, implies no complex root. There is another possibility. Yes, let us discuss these possibilities from the given cubic equation. Since f of x is a cubic equation, when you differentiate cubic equation with respect to x one time, its derivative reduces to second degree equation, and we know that second degree equation maybe that has 2 different real roots, or maybe it has equal roots, or third case maybe it has no roots. Here delta more than 0, discriminant suppose greater than 0 for f dash of x equal 0, then we can say that f dash x has 2 different real roots. If delta less than 0, it has no real roots, and if delta equal to 0, it has 2 equal roots. Yes, from the second degree equation you will get these 3 cases. Depending upon these 3 cases, we can decide the nature of cubic equation. Let us discuss different cases. First, case 1. Here you have delta more than 0 for f dash of x equal 0. Therefore, here I can write, since delta value more than 0 for f dash of x equal to 0 implies, I can say that f dash of x equal to 0 has 2 different real roots. Next, f dash of x equal to 0 implies the function has 0 slope for 2 real values of x. The meaning, f dash x equal to 0 means it has 0 slope at 2 different values of x. The meaning here, let us draw different cases to become slope of the function f of x 0 at 2 different values of x. Let us see geometrically. You know that f of x is a x cube plus b x square plus cx plus d equal to 0. It is a cubic polynomial. Here the condition a non-zero, B comma C comma D, they are real values. Yes. Slope of the given function should be 0 at two different values of x implies depending upon the value of e, we get different diagrams. Suppose the value of e more than 0 and the value of a less than 0. Let us discuss the different cases. Slope must be 0 at two different values of x implies you can draw third degree cubic polynomial as, let us see, this is x-axis and it is y-axis, and suppose that f of x is a function at two places, slope should be equal to 0. You will get, this is one type of diagram. Clearly here slope is 0 and here also slope of the function 0. Assume that this is one point x1 and this is another point x2. This is the case and this is the diagram when a value more than 0, remember. Next, suppose that a value negative. When a value negative, we get a reverse shape diagram, that is you will get the graph in this way. This is the graph. Slope 0 at two places, here and here. This is x1 and here it is input x2. This is one case, and in this case the function cuts x-axis at three different points and they are called roots of the given cubic polynomial. Yes, here x-axis intersected at three different points. First point suppose alpha, next point here it is beta, and here it is gamma. So in this case we can say that the nature of the roots, clearly it has three different real roots. Yes, here we got three different real roots in this case. Here I am going to write three different real roots in this case. This is the nature of the cubic polynomial. Whenever delta more than 0, f dash of x equals 0, and here also we can write in this case f of x1 into f of x2. F of x1 positive, f of x2 negative. In this case positive into negative become negative, and here f of x1 negative, f of x2 positive. So it product of these two here in this case negative. Next diagram, the same 0 slope at two different values of x. I am going to draw another diagram. Again, first condition a more than 0, after that a less than 0. Here I am going to draw. Suppose that the curve, if it is of this form, increasing, somewhere slope 0 and then negative slope and again slope 0 and then it increases. Here slope 0 and here slope 0. Particularly here suppose it is x1 and here it is x2. Slope is 0 at two different values of x. The same in the second case. In the reverse direction you can draw another graph. Yes, instead of this, reverse. reverse diagram I am going to draw. It crosses x-axis and then goes slope 0 and somewhere slope 0 in this way. This is the graph. Here slope of the function 0 and here slope of the function 0. Here it is of x1 and here it is of x2. Observe in this case it has only one real root. Why? Because the function f of x intersecting x-axis only at one point, so that here there exists only one real root alpha. Here there exists only one real root alpha. Yes, I am going to write here one real and remaining two complex conjugate. One real comma two complex conjugate in this case. Also here the condition f of x1 multiplied by f of x2 gives greater than 0 result. Why? Because f of x1 positive, f of x2 also positive, so that product of these two become more than 0. And here f of x1 into f of x2 more than 0. Next, third case, for a more than 0 I am going to draw. You can draw another graph with the condition 0 slope at two different values of x. That is, see here, suppose the function increases and slope 0 and after that decreases, slope 0 and then increases. Now let us see this diagram. Slope is 0 at two different values of x. Here it is x1 and here slope 0 at x2. But the curve touches the graph at one point, intersecting the x-axis at another point. It indicates that it has one different root alpha and remaining two equal roots. So beta repeated twice. Therefore here the roots are 3 real, in which 2 roots are identical. Yes, in the same way, for a less than 0 you can draw the graph. That is, you can draw the graph in the second case in this way. Yes, slope 0 here and here. The condition satisfied. 0 slope at two different values of x. And here there is one root alpha and the remaining roots are equal, beta comma beta. So that I can say that 3 real roots, but in which 2 are identical. This is the case. So whenever delta more than 0 and f dash x equal to 0, in this case f of x1, f of x2 less than 0 implies we get 3 different real roots. F of x1 into f of x2 more than 0 implies only one root, remaining 2 complex. And in this case f of x1 positive, f of x2 0. Here f of x1 into f of x2 clearly equal to 0. In this case 2 of the roots are identical, remember. Let us move second case. Suppose delta less than 0 for f dash of x equal to 0, Then let us discuss the nature of the roots in this case. Yes, since delta less than 0 for f dash of x equal to 0, the meaning here it has no real roots, implies I can write f dash of x equal to 0 has no real root. When it has no real root, implies I can say that no roots implies it doesn't intersect x-axis. Therefore, f dash of x not equal to 0 in this case. F dash x equal to not f dash of x is non-zero implies either f dash of x more than 0 or f dash of x less than 0. Implies I can say that f of x either increasing or decreasing function. So now you have to draw the graph that should be either increasing manner or in decreasing manner. Yes, I am going to draw the graphs. X-axis, this is y-axis. Two cases arises. Maybe the graph increases or decreases. Slope never 0, remember. Slope never 0 implies only one case arises. The function may be increasing or may be decreasing, depending upon the value of a. Suppose a value is more than 0. Second case, a value is less than 0. When a is more than 0, we get increasing graph in this way. When a is less than 0, you will get decreasing graph. Here, the function that crosses x-axis at only one point implies it has only one real root, remember. Here, this is alpha. Therefore, I can say that cubic polynomial f of x equal to 0 has only one real root and remaining two complex conjugates, remember. The same here you have to write f of x equal to 0 has only one real root and two complex conjugate in this case. Delta less than 0 implies no real root. No real root implies it doesn't intersect x-axis. That is, f dash x is never 0. So maybe more than 0 or greater than 0. Therefore, maybe increases or decreases implies it gives only one real root, remember. This is the second case. Let us move to the next case. If delta equal to 0 for f dash of x equal to 0, then let us discuss the nature of the roots of f of x. First, since f dash of x equal to 0, if discriminant equal to 0 implies, I can say that f dash of x equal to 0 has real and equal roots. When it has real and equal roots, I can write f dash of x as real and equal. So, suppose that alpha is repeated root. Here, from the given data, f dash of x whose x square coefficient is 3a, therefore here I can write 3a of x minus alpha into x minus alpha gives 3a x square. Yes, and implies f dash of x written as 3a of x minus alpha whole square. Applying integration on both the sides, 3 outside here, integration of x minus alpha whole square into dx, and hence f of x is equal to 3a into, this is x minus alpha whole power 3 divided by 3 plus integral constant. Implies you can write f of x equal to 3 gets cancelled here, a of x minus alpha whole cube plus some integral constant. So f of x, you got the function f of x, a of x minus alpha whole cube plus some constant. It is very clear that when the value of k equals 0, f of x has 3 equal roots, alpha, alpha and alpha. Let us see here, two cases arises. Suppose the value of k equal to 0 and k is non-zero quantity. What happens? Observe. If k is 0, f of x written as a of x minus alpha whole cube. X minus alpha repeated thrice. Therefore, x equal to alpha, alpha, alpha. Implies I can say that 3 real and equal roots exist in this case. That's all. Next, suppose k is non-zero quantity. When k is non-zero quantity, f of x equal to a of x minus alpha whole power 3 plus some constant we have to write. And let us discuss the nature of the roots. To get roots, I am going to equate with 0, and from this you can write a of x minus alpha whole cube equal to minus k, implies a of x minus alpha, only x minus alpha whole cube, that is minus k divided by a, and you can write x minus alpha value cube root of minus k divided by a, implies x value become alpha plus cube root of minus k divided by a. Yes, cube root function is defined for all values, real values of input, so that I can say that x has only one root. Therefore, f of x has x equal to, we got alpha plus 3 root over k minus a. Cube root of x is defined for all real values of x. So alpha plus cube root of minus k by a gives only one quantity, so that f of x has one root in this case. Yes, that's all. Only one root in that case, and in this case 3 real and equal roots. This is about the nature of roots of a cubic equation. You people are familiar with nature of roots of quadratic equation, but in entrance point of view, in JEE mains and advanced examinations, it is very important, the concept of nature of roots of cubic polynomial, and the nature of cubic polynomial here, that is depending upon derivative of the function. Remember, after applying derivative, you got f dash of x, and f dash of x equal to 0 has 3 different cases, and in each case you have different roots. When delta more than 0, 3 cases arises, maybe 3 different real roots, 1 real root, or 3 real in which 2 are identical. Next, delta less than 0 implies only one real root, remaining two complex conjugate. In the third case, delta equal to 0 implies I can say that it has at least one root. Why? Because in one case we got 3 real roots, in the other case you got only one root, implies overall I can say that when delta equal to 0, the function f of x has at least one root, remember. I hope you understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.